Welcome back. And today the lecture we are going to talk about the meshing. So from the website CSI Knowledge Base, a mesh is a network of line elements and interconnection nodes used to model a structural system and numerically solve for the simulated variable under the applied loading. Yeah. And in CSI we have two options for meshing. The first, auto meshing, and also manual meshing. Auto meshing is the default program we mesh for our model, for slab and beam, and also. And for the manual meshing, the user can insert and separate the width of the element by themselves. And for this knowledge from the CSI knowledge base, per review suggested that we mesh our model manually. What should we do? The answer: automatic and manual mesh. We produce comparable results. Manual meshing is much more time consuming. This that we mean that the manual meshing the program running will take more time from the automation, because the user will insert the number is smaller than the automation. And for the further the sophisticated automatic meshing produced of CSI software may even produce a more efficient and reliable mesh. Controls are available to manually refine, and automatic mesh refinement may improve the modeling and analysis origin with the stress, concentration, extreme force, gradient, member connection is strong. So back to our Etabs. Now we are going to mesh for the slab. To mesh for the slab, the first we need to select all the slab if we want to mesh. We go to select, and we can select property, slab section. So I select the S12, select and close. And we go to assign cell floor auto mesh option, and auto copy cut object to structural element. I take this one. And further mesh where needed to maximum element size. I insert 500, and also I take add restraint on edge if corner have restraint. Apply and OK. This. And also for the beam, select property, frame section. This all beam, select and close. I could assign frame auto mesh option, and auto mesh option apply and OK. And next we select the wall section, V20, select and OK. I go to assign cell wall automate option, advanced modify, so rectangular. So I use the size from 1.25 to 0.5 and OK, apply and OK. Yeah. And also for stair, go to select property and slab section, expand stairs, and we assign cell floor. Also the same thing, apply, OK. Okay, for the next we will apply diaphragm to the model. So from the ACI code, we can refer to ACI 318-14, the chapter 12 diaphragm. And how diaphragm works. Diaphragm design, so consider A slot E. For A, diaphragm in plane force due to the lateral load acting on the bedding. Diaphragm stands for the force and connection force between diaphragm and vertical framing or non-structural element. Force resulting from the pressing, vertical or slope bearing element. Diaphragm are plane force due to the gravity and other load applied to the diaphragm surface. And also, diaphragm has two options, rigid diaphragm and also semi-rigid diaphragm. The rigid diaphragm hold infinite in-plane stiffness property, and therefore they neither exhibit membrane deformation nor report the associated force. Semi-rigid diaphragm simulate actual in-plane stiffness property and behavior. And also, profoundly different formulation, the finite in-plane stiffness component of the rigid diaphragm allows the stiffness matrix to condense, decreasing computation time, eccentricity, and reporting force. Yes, so to define the diaphragm in this step, we go to define diaphragm and select D1 and modify diaphragm. Here we choose the rigid diaphragm and OK. And to apply diaphragm to all the floor in our model, the first we go to select option, go to property and slab. I will select S12. I select all the slab every floor, select and close, and go to assign cell, and we choose the diaphragm and select D1 and apply and OK. Here the diaphragm that connects all edge of the slab to the center of the mass. Okay. So the next we going to talk about the load for the building. Load on building, there are many types of load in the building. The first dead load. Here we mean about the surface, all the element that we draw in the model is defined as the load and the surface. And for the second is the superimposed dead load. This we refer to the permanent load such as the floor tiles and also the partition wall. And line load, this means the non-permanent load such as the load of people and also the load of furniture. And the wind load will refer to the wind pressure and also the wind force. Roof line load refer to the load of the people that going to the rooftop and for repair purpose. And seismic load is the seismic we can define from the seismic criteria. And soil pressure is the pressure of the soil that acts to the retaining wall or the basement wall. And void pressure, also the pressure of the water that acts to the swimming wall or swimming pool and retaining wall. Okay, so in our Etabs we can define this type of load by going to define and for the load pattern. Here Etabs also have two type of load in default. Dead load, this means the surface, and the line load, this means the line load. So we will going to define the superimposed dead load and also the wind load and also the roof line load. For the seismic load, soil pressure and wind pressure, water pressure, in Cambodia we don't have any history record about the seismic, so we will not define this load. And for the soil pressure, our building they are not basement, so we will not only define the soil pressure. And also the water pressure, we don't have any swimming pool in our model, so we are not going to define the water pressure. So now we will go to define the superimposed load, the wind load, and also the roof height load. Now for the load, we can write SDL is superimposed load. The tab should be super that, and cell weight multiply should be 0 because we are not going to include any cell weight for the element. Add new load, and also the wind tab should be the wind, and auto lateral load we are going to design follow the ASCE code by 7-16. Add new load, and we are going to talk about the modified lateral load later. And another is the roof line. The tab should be the roof line. Roof line. Yes, and add new load. So for wind load, we are going to talk more about the modified load. And from here, follow the ASCE 7-16, the exposure and pressure coefficient, because we already applied diaphragm to our model. So for my option, I will choose the first option, exposure from the extent of diaphragm. But if you want to define the wind load and the wind pressure by manual, and you can choose the second option, and you need to apply from the calculation note that you calculate it, and to the cladding that you draw for each side of the building. So I will go back to the first option because I applied diaphragm. I apply wind load by using a diaphragm. And also for the wind pressure coefficient, you can define the windward coefficient and the leeward coefficient by menu and input to this box. And also you can let the program determine. So talk a little bit brief about this. This is the coefficient of the windward, that the wind act to the surface of the load, out of the building. So we can define by menu to get the CP, and also to get the wind coefficient of the windward, and also the leeward. This coefficient of CP. And but for my option, I will let the program determine by I will follow the program. And also the wind pressure parameter for wind direction and pressure width, we can modify. After you apply the diaphragm, the program will determine the width and the depth automatically. So this I will let before. And case I will create all set of case, because follow the ASCE. Because follow the ASCE, we have full case. We have 4 case, and this I will follow the code, and I will choose all set of this. And also the E1 and E2 we can define from the code. Refer to the ASCE 7-16, the page 338. This is the E1 and E2. E1 refer to the H direction, and also E2 the Y direction. We can, this is coefficient 0.15. We can input to our software. For the wind coefficient, wind speed, the measure, the unit is the mile per hour, but I can convert. For example, I define wind speed about 200 km per hour. Per hour. So should be 74.5 565 miles per hour. So now I will design our building based on the wind speed is 120 km per hour. So I copy and apply here, and its postal type in ASCE code they divide into three category of the location. For the type B, the urban and suburban area, and for the type C is the open terrain and scattered abstraction. That how high generally less than 30 feet, about 9.1 meter, and also the type D, the flat area, and especially to the sea area. And this area that we can define here for more understanding. This is the type C, that we less which means the open area without tree, without the building. And for the type D is refer to the sea area, and the type B refer to the urban that have some of taller building and also some of the tree. So for my option, I will choose the type B, and ground elevation factor. Ground elevation factor we choose 1, and topographical factor K sub T refer to the topographic factor. We can define from this formula, but actually if the site condition and location of building and other structure do not meet all conditions specified in the section 26.8.1, K sub T should be equal to 1. And this section the section 26.8.1, the wind speed up over the hill width and escalation we can read, but our building is not meet the criteria, so I will choose the K sub T equal to 1. And gas factor, for gas factor, the gas effect factor for a rigid building or other structure is permitted by taken as 0.85. So I will let here is 0.85, and directionality factor KD. From the table 26.6-1, wind directionality factor KD, our building main wind force resisting system. This is our building type, so I will choose 0.85. And if your building match to another section, you can follow this number. So for the KD, I choose 0.85, and the exposure height, the top story should be the roof, and the bottom story I choose from the ground floor. And I'm not going to include any parapet wall, so I click OK and OK. So now we are going to calculate the dead load and the live load to apply to our model. So refer to our MathCAD. We can define our superimposed dead load from this calculation, the calculation of dead load on floor. So the design load on floor for slab. Our slab we have a mortar. We choose the thickness about 40, and ceramic ceiling 0.2, and mechanical 0.2, and other load we refer to the partition wall. So superimposed load for for me is about 2.42 kilonewton per meter. And also calculation the wall load. If you want to apply the wall load or wall 20 or wall 120, you can calculate based on this formula. The void volume of brick, a hollow brick that we have 4 holes for our single brick. Then the diameter of one hole is about 30 millimeters, so I can define the whole volume from the formula. And also the load for 1 meter square of brick. 1 meter square of brick have about 55 set of brick. So we can follow this formula. We get the wall 10 wall 100 millimeter and wall 20 wall 200 millimeter for this amount. And also to calculate the wall height, wall load height run or running 1 meter, we start from the first floor to the up floor, and we use the dip on the beam. For example, I have the beam section about 500 and the floor height about 300.5. So I calculate, I take a floor height about 3.5 minus the dip on the beam and multiply by the wall 10. I get about 5.156 kilonewton per meter. And for wall 20 about 90.74 kilonewton per meter. And also for the staircase, we can design based on the IBC code. And for example, this staircase, I take a landing of stair L about 3 meter, and width of the landing of B for 1 meter. Height of the landing, we can take the floor height divided by 2 of 1 meter, 1.78 meter. And also the number of our research, number of step, 11 of step, and treat and research dimension. The treat 300 millimeter and research about 162, and thickness of width, about 125, or we can take only 120, and thickness of landing also 120. And also a slope we can calculate by this formula. And so for the width, dead load on width, we can calculate from here. So the total dead load on width about 8.08 kilonewton per meter. Finishing this, we include also the slab width, we mean the survey, but actually we to reply in the Etabs that the survey program already consider, so we can omit this with survey. So the total dead load on width about 4.6 kilonewton per meter. And line load, we can follow the staircase design ASE 0.6, but this line load we for the public stair, but for our building residential 1 or 2 unit, we also the line load can be used to 2.4 kilonewton per meter. Also for landing, for seismic and bedding, and also rendering, and total the dead load on landing, we delete the survey. So the total dead load about 2 kilonewton per meter, and also the line load about 2.4. Yeah. Okay. So go to our model. But remember, for our project, for the ground floor, level 1 to level 2, we use for the office space, so the line load are different. So follow the ASCE. Okay. So follow the ASCE code 7-16 page 69 for the office building, the office space about 2.4 for line load, and for the residential area about 2.9 T2 except stair, and also the stair. Yes, the stair exit and exit way for 1 and 2 family we can use to 1.92%, but in this case I will choose 2.4. Okay.